Question number 2, straight into our power rule that says that the integral here must be x to the negative 1 over negative 1, which is really 1 over x. So we want to solve 1 over x from 2 to infinity. Sorry, negative 1 over x from 2 to infinity. Let's plug in infinity using our limit definition. So limit as b approaches infinity of negative 1 over b minus negative 1 over 2. So the limit b approaches infinity of 1 over x, well, it's, again, one of the first things here, 1 over infinity, we know converges to 0. So the limit as b approaches infinity of negative 1 over infinity, this converges to 0 plus 1/2. So our answer is 1/2. Let's check the answer key. Yeah. Okay, question number 3. Okay, the integral of e to the 4x. The integral of e to the 4x is e to the 4x over 4. And you can take the derivative of this to prove that. Integrated from negative infinity to 0. Okay, we'll have e to the 4 times 0 over 4 minus limit as b approaches negative infinity of e to the 4b over 4. And let's simplify this. Well, e to the 4 times 0, 4 times 0 is 0, e to the 0 is 1. So this is 1/4 minus the limit as b approaches negative infinity. Using our shorthand, rewrite this term as 1 over 4e to the infinity. Now, e to the infinity is infinity, 4 times infinity is infinity, and 1 divided by infinity is 0. Remember, 1 divided by infinity converges to 0. Our answer is just 1/4. 1/4 is our answer. Question number 4. This one took quite a bit. So before we jump into this, please remember that the derivative of arc secant x is 1 over the absolute value of x times x squared minus 1. Let's factor out 4. So let's rewrite this as the integral from 2 to infinity of 1 over x root 4 x squared over 4 minus 1 dx. And the square root of 4 is just 2, so we can rewrite this as 2x. 1 over 2x square root. Now, x squared over 4 can be written as x over 2 squared. Okay. So we're getting closer to the secant, but this x and this 2x here needs to match this x over 2. So what we could do is rewrite 2x as 4 times x over 2, or jump straight into the u substitution. Both will work. Let's do the u substitution at this step just to show that it works without using any tricky algebra. But I will highlight this here just so you know that we could have rewritten this as 4 times x over 2. Using u substitution, we get the same answer. So let's let u equal x over 2. That means du is 1/2 dx. So that means that 2 du is dx. All right, so let's rewrite this as 1 over 2u equals x. So we can use that here, and we'll get the same thing. So 2x is 4u. U was x over 2 from 2 to infinity. The limit as some number approaches infinity of the arc secant of that number over 2. Essentially, as b approaches infinity, what happens to arc secant? Arc secant of infinity, essentially, is some number x. We're going to solve for x. Take the secant of both sides. The secant is 1 over cosine. Swap these two. Remember, 1 over infinity converges to 0. Cosine of x equals 0. And since we're talking about the inverse trigonometric functions, when we find which values of x make this true, we're going to take the first value, the value closest to 0. Cosine of what angle equals 0? Pi over 2 or 3 pi over 2. But again, we're not counting that second value because we're talking about arc secant, and this is two outputs, essentially. This is break the vertical line rule for a function. So we're only going to take this value of pi over 2. So long story short, the limit as b approaches infinity of arc secant of b over 2 is simply pi over 2. Okay, now let's plug in 2. So minus arc secant of 2 over 2, which is the arc secant of 1. And in case you don't have that memorized, let's check that again. Let's do the same thing. Let's say arc secant of 1 is some other value. Secant of both sides, we get 1 equals secant x. 1 over cosines, we get 1 over cosine x. Swap these, we get cosine of x equals 1. Therefore, x must be 0. Okay, so we just determined that the arcsecant of 1 is 0. So we're left with uh, 1 half of pi over 2 minus 0, which is just 1 half pi over 2, which is pi over 4. Pi over 4. What happens when we take the integral from 0 to 1 of 1 over x to the p when p is greater than or equal to 1? That is what they're asking us here, where p is 7 over 5, which is definitely greater than or equal to 1. Your instinct should tell you that this diverges. Also, you saw me erase the word diverges, but let's prove that it diverges by rewriting this as the integral from 0 to 1 of x to the negative 7 over 5 dx. Applying power rule, so negative 7 over 5 plus 1, which is really plus 5 over 5, gives us negative 2 over 5. So x to the negative 2 over 5 over negative 2 over 5. Integrated from 0 to 1, negative 5 halves, and rewrite this x to the negative 2/5 as 1 over x to the 2/5, integrated from 0 to 1, bringing down a negative 5 over 2. You get 1 over 1 to the 2/5 minus 1 over 0 to the 2/5. We could take the limit as b approaches 0 of 1 over b to the 2/5, because plugging in 0 directly would give us undefined. But again, the limit as b approaches 0 of this is actually infinity. Because we have this infinity, this diverges. Let's rewrite this using partial fraction decomposition. So in case you forgot, we're going to take our fraction 3 over x times x minus 1, and we're going to say that that is the equivalent to some number over the first factor in the denominator plus some other number over the second factor in the denominator. Okay, and then we're going to multiply to get common denominators. And now that the denominators are equal, we can set the numerators equal. So essentially 3 equals a times x minus 1 plus bx. Okay, and so now we're going to solve for a and b by letting x equal 1 and x equal 0. We can rewrite our integral. And we're going to solve these. We could definitely split these up into two separate integrals. Okay, so distributing, we have negative 3. Applying this limit, we have negative 3 natural log infinity, which is infinity. But when we distribute negative 3 times negative ln, we get plus 3 times the natural log of 2, plus 3 times, again, applying infinity to this limit gives us the natural log of infinity. Using shorthand, this is definitely shorthand here. This is our application of the limit. Don't get into the habit of doing this without remembering this is an application of the limit. This is shorthand. Infinity is not a number. Okay, and then natural log of 1 is 0, so you don't even need to write it, minus 0. Okay, next we see that 3 natural log of infinity and negative 3 natural log of infinity, those two terms will cancel out, and we're left with 3 natural log of 2. So let's check the answer key. Yes, 3 natural log of 2. I hope this was helpful.